Greetings and welcome. Today, we will be using CET.SteelConnDesign to design a beam-to-column single-plate connection in Tekla. In our previous videos, we discussed how to download and install our software. If you missed that, please check out our channel. We assume that Tekla is installed on the user's computer. For demonstration purposes, we have already created a steel frame with 2 columns and 2 beams. In order to use our software, each member in the Tekla model should have its unique name. For instance, the column names could be C1 for the left column and C2 for the right column, while the lower beam could be named B1 and the upper beam could be named B2. This is very important because we use member names to identify each connection. If you have trouble renaming an existing Tekla model with hundreds or thousands of members, please email us. We can create a small software program to automatically rename the members. It's important to start our system after Tekla, as we need to establish a connection with the running Tekla program before initiating any actions. You'll also notice that our system has 2 tabs. The first one is about projects and the second one is about connection design. On the left side of the Projects tab, you can select the design code or enter details such as email address or company name. On the right side, make sure that Tekla is selected as the model provider. The Load and Save Project buttons are reserved for future use. The Scan Model function is recommended and will bring the member information from Tekla into our system. When you click the Scan Model button, you will see the message as 4 members from Tekla have been read into CET model. Now we have B1 and B2 in the beam list and C1 and C2 in the column list. To create a connection from beam B1 to column C1, we need to make sure that both B1 and C1 are currently selected. Also, beam to column flange is selected in the connection setup. Clicking the Create Connection button will create a B1_C1 connection and add it to the connection list. Our next step is to establish a connection between beam B1 and column C2 while taking note of the 90-degree rotation of C2. We will start by selecting C2 from the column list and opting for Beam to Column Web in the connection setup. Subsequently, we will create the B1_C2 connection, which will be appended to the connection list. If something goes wrong during the process, you can delete the connection and recreate it by fixing the errors. Now go to the Connection Design tab. Here we can see that we have 2 connections in the list and we can select B1_C1 for the design. The Design Parts combo box holds the most significance, as it allows us to choose between the beam, column and web connection options. For beams, we can change the loads. For example, we can change the shear load to 35 kips and design the connection by clicking the Design Connection button. If the design passes, the user will see that a B1 to C1 single-plate connection has been created in the Tekla model. If we continue to modify the shear load to 15 kips, we will see that the connection has been shortened with 2 rows of bolts. For later use, we will change the shear load to 33 kips. For both beams and columns, we recommend that you let Tekla control the member sizes. For the web connection, there are 3 tabs: the General tab, the To Beam tab and the To Column tab. In the General tab, we can change the plate grade or change the type of joint. In this version, our system supports only single plate. Soon, we will support more types like end plate. Now we change the vertical position of the plate to middle. After the design, the plate position is updated in Tekla. If we click the Undo button, the plate will move back to the previous position. We can also move the plate to the right side of the beam or undo the last operation to move it back. For other fields, the plate length, width, thickness, and distance from the plate top to the beam top can be entered. For instance, the distance to the beam top can be set to 1.5 inches. Note that the input fields, such as plate length, are highlighted in cyan to indicate their values. Our system offers 2 unique features. Firstly, users can leave some fields empty, and the system will generate values for the user. Second, the system-generated values will be highlighted in cyan to differentiate them from user input. According to the AISC manual for plate configurations, we have the option to choose between the extended or conventional configuration. If unsure, it is recommended to choose the extended configuration. Now we change the shear load to 20 kips for later demonstration. In the To Beam tab of the web connection, we have the option to select the bolt type or hole type. For instance, we can choose the long slot transverse to load hole type and design it as a slip-critical bolt. We also have empty input for bolt diameter. After the design, the user will see that the long slot holes have been created in the Tekla model. If we undo these changes, the hole size will return to its original value, and the bolt diameter will be 0.875 inches, which was the user input value. Again, in certain fields, our system allows the user to leave certain values blank. For example, in the bolt diameter field, if no value is entered, the system will automatically design for a bolt diameter of 0.625 inches. However, if a value of 0.75 inches is entered, the system will use that specific value for the bolt diameter. As we select different tabs, the image on the left changes to provide visual aids. These images demonstrate the meaning of some of the input fields, assisting the user to enter the correct values. For example, we can locate and adjust the To Connection Face Transverse to Load field and set its value to 2.5 inches. After the design, the single plate will appear wider based on the newly adjusted value. We can also change the edge distance parallel to load to 1.5 inches and make the plate longer. In the To Column tab, we can adjust the weld size. The Summary tab on the left panel displays a concise design summary, which provides an overview of the connection capacities without the need to open the full report. By changing input values, such as the shear load to 10 kips, the corresponding values in the design summary will adjust accordingly. Clicking the Show Report button displays a comprehensive HTML report containing 3 main sections: a general information section, a summary section, and an equation section. The equations within the report are presented in a visually appealing format using LaTeX syntax. You can print the report in PDF format for later use. To design the connection between beam B1 and column C2, the next step is to adjust the view in Tekla to achieve a better viewing angle. Once we have a satisfactory view, we select B1_C2 from the connection list. Clicking on the Design Connection button initiates the connection design process, which updates the 3D connection model in Tekla. We can make several modifications as the first connection, such as relocating the single plate to the right of the beam in the Web Connection tab. And that concludes our presentation for today. We appreciate you taking the time to watch.